This week we're getting into temperatures. Well, we've talked about the overall atmosphere, and we've got in a little bit of where all the energy comes from. Well, we learned also that a lot more sun's energy comes into the tropics than does to the North Pole area, and the fact that the Earth's constantly rotating, we're getting different amounts of energy at different spots all the time. So the Earth is always trying to eliminate that difference in energy. So what are some of the causes and consequences of this heat transfer within the Earth's atmosphere system? So all matter is composed of molecules, particles, whatever, that vibrate, have some rotational. So there's a certain amount of kinetic, which is energy in motion, in every particle out there. So the more kinetic energy, the more that particle is moving. The less that particle is moving, the less kinetic energy. Well, temperature is directly proportional to that. So, assuming that the temperature is higher, then those atoms are moving faster. Temperature is lower, they're not moving as fast. And heat, just energy in transit, is moving from one object or one thing to another. So we have temperature gradients all over the Earth. And per the second law of thermodynamics, that heat flows towards lower temperatures to eliminate that gradient. So it's always trying to get rid of lower temperatures. It wants everything to be the same temperature. So with that, in fact, how does heat transfer? What are the methods that this can happen? Well, radiation. We've talked some about that, how the energy from the sun transfers to the Earth through radiation. Conduction, convection, and latent heat, which is just phase changes in water. So radiation is a form of energy that can go through a vacuum, can go through air, but it's a way of transferring energy through electromagnetic radiation. So say you stand outside, you're in a shaded spot. Bright sunny day. You walk outside, you walk from that shaded spot into a bright sunshine spot. Which one feels hotter to you? I will bet you it's the sunshine spot. Why is that? Because you're receiving the radiation. Energy is being transferred to you through radiation. Go back into the shade, there's less energy coming to you. Conduction. Think about this in the summertime when it gets really sunny and beating down on the asphalt, black asphalt somewhere. That asphalt gets really, really hot. Remember, black absorbs radiation basically. And if you were to touch that, you're going to burn your hand. Or somebody used to say you could cook eggs on it in the summertime when it gets so hot. That transfer of energy between the touch is conduction. It's literally molecules in the black asphalt hitting that egg or your hand, whatever, that are transferring that energy. Some things can conduct energy very well. Gases aren't one of those. They don't conduct very much as far as being in conduction. However, solids do, which is why asphalt, metal pipes, whatever, conduct the heat very quickly. And then you have convection. Convection is something unique to air. It deals within a fluid. You have energy moving from one object to another. In other words, it's heat. Literally, the air is hot air rises, so we know. So we go upwards. As it's going up, it's cooling because the air is expanding. So it is transferring the heat from the ground up into that little cool cloud right here. Now, that cool air comes back down, gradually warming till it gets back down to the ground because it's getting compressed. That cycle is convection. If you look at cumulus clouds in the summertime, they're a part of that. This is a process that's constantly going on in the atmosphere. Every time the sun comes up, convection begins to develop. It may start very close to the ground. It may work its way up really high in the atmosphere. And when you add convection and conduction together, you're getting sensible heating. Notice there's no mention of liquid here at all. No water. So now we're going to get into water. Well, guess what? Water does transfer a lot of heat in the atmosphere. It's called latent heat. So say you go from a vapor, water vapor, and you condense that vapor. Well, those molecules just got tighter together, right? So by the fact that they got tighter together, they have less energy. So that means they released that energy. Somewhere had to go, that energy. They released it in latent heat. So when there's condensation, latent heat is released. And the same holds when it goes from a liquid to a solid. Latent heat is released. Now, go the other way. Goes from a liquid to water vapor. Take a day when it's rained a lot. Why would that next day, where the ground is real wet, even though there's bright sun behind, be slightly cooler? It's because there's evaporation. All those puddles, all that wet ground are evaporating, and that uses heat. So instead of heating the air, you're heating the water to evaporate it. So you don't have as much heat to do in the air. And these water makes a huge difference in climate. So I hear you have 3 examples. St. Louis is in literally the middle of the country. It has wide ranges in temperature from beginning of the year to the summer to the winter. Now, you go to San Francisco. It's right by the water. Oh, yeah. We have mainly west winds into San Francisco. That water temperature does not change a whole lot. So even though less sunshine is there in the wintertime, you're not cooling off as much compared to where you have a drier climate like St. Louis. So maritime areas are significantly influenced. It takes a tremendous amount of energy to heat up water. So that is one of the things where air is much easier to heat up, but water is not. So if water is not taking a long time to heat up, and I'll give you an example right here by the Atlantic Ocean near me. Starting in March, the sun is probably getting pretty strong here, late March. So at that time, the water temperatures here are usually in the 40s. It takes good sunshine and everything to get the water temperatures into the upper 60s by the early to mid-June here. Yes, that's 20 degrees, but it had a lot of heat. And by the same token, the air temperature went upwards from temperatures in the 50s or low 40s all the way into the 80s and some 90s. Significantly better rise. Now, maritime does affect my climate as well. I get some air off the ocean sometimes, particularly in the wintertime, for major storms coming that might keep my precipitation as all rain because the ocean is so warm. So water has a huge impact on temperatures. Here you can see the radiation that comes into the earth. We talked about this last time, that this is complicated. 47% of the radiation from the sun is absorbed by the earth's surface. However, a bunch of it is re-emitted back out from clouds, scattering it. The surface, there's an albedo, may scatter the radiation back out. And some of the long waves, you get greenhouse gases may absorb some of that long wave radiation energy and bring it back down to Earth. But some of that is also reflected back out to space. So this is a complex budget of how the Earth is heated from the radiation. And here you can see the convection, and specifically in cumulus clouds. So in the tropics, or a little bit out of the tropics, we actually have a surplus of radiation coming in. If it wasn't transferred anywhere else, the radiation temperatures in the tropics would even be hotter. But there's a deficit of radiation up to the north. So all that extra energy has got to get somewhere out of there. How that happens? Storm systems, air masses, ocean currents, all of that move that heat around. And air mass is just a big volume of air at the same temperatures. Tropical storms move a lot of heat to the north when they develop. By the same token, the strong extratropical storms we're going to study move heat up out of the Gulf with an exchange of air masses. So all this imbalance is what causes all these circulations to happen in the atmosphere. This is the root of all weather. During the daytime, guess what? One of the first questions you were asked in critical thinking was, why does the afternoon temperature hotter, the hottest time of the day? Well, here it is. During the day, the sun's up. It keeps heating all day until it goes down. So there is a surplus of incoming solar radiation till mid-afternoon. At that point, the Earth is heated enough that outgoing radiation balances it. That's when your maximum temperature occurs. So it occurs in mid-afternoon. After that, the Earth is fairly warm, and so is the atmosphere, but you're losing solar radiation, so your temperature drops quickly for a while. Then it slows down after that. So surface impacts the budget as well. Snow cover. That's why a lot of times after it snows, it can a high albedo. It doesn't warm up very fast after it. And this is just an urban heat island effect. You can see downtown DC is warmer than the areas around it due to all the buildings that are there. They have an airport at Washington National. It has had an observing site since the 1800s in that area. But when you look at how it has changed, the urbanization has settled in there, you can see temperatures have steadily risen in that area, whereas you go outside of that area, yes, they're rising some, but no comparison to how much temperatures are rising around Washington National due to the more and more people and more buildings being built there. So finally, I just wanted to look at, we talk about advection, air masses moving in. Well, here you see temperatures in the 50s. What do you see with the winds? The winds are out of the north here. So these 50s are trying to move into down here into Oklahoma, where the temperatures are in the 70s, and on this side of the front, maybe even close to 80. So this is cold air advection. If the winds are blowing in colder air, that's cold advection. Along the East Coast today, lots and lots of 80s right off the coast here. And guess what? There's southeast winds here. So what it's got? It's got a warm front trying to push this warmer air in. And you can see there's actually relatively cool air here. And finally, just looking at cloud cover, it's amazing what cloud cover can do for you. Notice here over the mountains in parts of western Virginia, West Virginia, lots of clouds. It's a fairly cool day. I'm over in this side of the world where I have some more sunshine. I'm about 10 to 15 degrees warmer than where all the clouds are. So you can see clouds impact this as well. So hope you got something out of this and got a little bit of a feel for temperatures now. Let me know if you have any questions.